Well, hello there. How are you today? I hope so far we have done 19 topics altogether. It's covered pretty much half of the semester of the material that we are going to complete. Okay, so today we're going to start a new topic. Okay, last two topics. Okay, RC and Rl circuit. You see that the questions or examples that we have done would consist of several resistors in the circuit, but pretty much a capacitor or an inductor. Okay, so we call it RC or RL. Okay, so we have one storage element, either a capacitor or an inductor. So today we're going to start with a circuit that has two storage elements. Okay, two storage elements. Okay, and of course those two storage elements cannot combine, using series or parallel combinations to reduce it to one single storage element. Okay, so the simplest one that we're going to study, okay, is called, of course, Rlc circuit. So therefore you see that we would have an inductor and a capacitor. Okay, so we have two storage elements. Okay, so let's start with the simplest one and see what's the difference between this Rlc and the one we did before, Rl or Rc. Okay, so let's say that we have Rlc connected in parallel. So if this is Is of t, okay, and of course they are parallel, so they have only one node up here. This is ground, so there's a voltage drops across all these elements, go to V, so R, L, and C. Okay, so this is, well, of course the current Is comes up, okay, out of the source, then it would divide it into IR into L and into our capacitor. Okay, so of course we have things in parallel, so therefore we write KCL, we sum the current together at V, KCL at V, so you would have our IR, right, plus IL plus IC equal to IS. Okay, right? Well, it doesn't seem to, well, what is this? Well, I can't solve for anything, right? So I'm going to express this in terms of the voltage drop, V. Well, IR is, of course, from Ohm's law, V over R. Okay. Well, for the inductor, the relationship, the formula is VL equal to L di by dt. So in this case, it would be V equal to L dIL dt, correct? But I want IL, so you have to integrate, right? So therefore it's plus 1 over L, integrate from the initial value t to any t, right? Vx dx plus IL at that initial values. Okay, so that's IL. And IC, of course, the relationship for the current through a capacitor is C dV by dt equal to IS. Well, of course, we never like integrations. We don't leave integrations in the picture, so therefore we integrate. We can differentiate with respect to time, across the equations, the entire equations. So therefore, you will have, right? Well, I'm going to just do it, right? So if you differentiate this one, it will become C d square V dt square, right? If you differentiate V over R, it becomes 1 over R dV dt, right? And then we differentiate the IL, so equal to V over L equal to dis dt. So therefore you can see that if we do it like this, so 1 over RC dV dt plus V over LC equal to 1 over C dIs dt. So therefore you will get what it's called the second order differential equations. Second order differential equation. So therefore those who, well, you should in your math class right now, right, with our curriculum, you should be doing this second order differential equations in your math class, your parallel to this. So you know that why it's so important in your math class to pay attention to your math class, to understand how to solve first order differential equations and second order differential equations. So these are the applications that you can, you know why you learn those math things. Now about another one. If I have RLC circuit but connected in series, right? Okay, well, CC, of course it can be interchangeable, the positions, right? VS R C L. Well, of course the current going through this, current I, okay, the current I going through R, so there's a voltage drop VR, voltage drop VC, voltage drop in voltage induced in inductor. Well, it's connected in series, you add voltage up, so therefore you write KVL of this loop I, and of course you would get what? VR plus VC plus VL equal to VS. I'm going to express all this in terms of the current, right? So therefore VR is R times I, right? VC is 1 over C integrate I x dx plus VC at T naught. Well, this is T naught till any time T, plus of course VL is L di by dt equal to VS. So when you do the same thing, differentiate it with respect to time across the equations, rearrange it, you will get L d square I dt square plus R di dt plus I over C equal to dVs dt, or d square I dt square plus R over L di dt plus I over LC equal to 1 over L dVs dt. Second order differential equations. And you have to solve for the current. Okay. Now, right, so this is all you need your expertise in your math, But since I know that some of you may not have had this math course, I will do some review and sort of like a short, brief summary of how to solve this. Okay, so let's review second order equations. So review second order equations, and of course I'm not exactly a math teacher, right? So therefore I may not say wrong vocabularies and things. Okay, but okay, so second order differential equations, the general form is d square x dt square plus a1 dx dt plus a naught x equal to f of t, right? So x could be anything, right? So for if you compare to this equation, so it's your I, right? A1 is R over L, A naught here is 1 over LC, and your f of t is 1 over L dVs dt. Okay, you can compare it like that. Let me go back, I don't want that arrow. Okay, now whenever you have this form of equations or second order differential equations, the general solution to this is to this is, right, your solution x of t, right, would consist of, again, okay, xn of t, the natural response, and xf of t, the forced response. Okay, so therefore, this is your natural response, and we have to set f of t equal to 0 to solve for it. Okay, and this one is called the forced response. Okay, and you have to solve the actual differential equations. Okay, so let me write. So this case, this is the solution to, right, d square x dt square plus a1 dx dt plus a naught x equal to 0. And this one you have to solve d square x dt square plus a1 dx dt plus a naught x equal to f of t. So you have to find these two solutions, xn and xf. All right? Well, let's do natural response first. So we're going to find a way to find xn of t, the natural response. Okay, so let's do it. So that means we have to solve d square x dt square plus a1, can I write out n here, da1 dxn dt plus a naught xn equal to 0. And I'm sure you can, go and read more detail in your math class. But for us, we're going to assume that, okay, our solution xn, okay, is in terms of k e to the st, right? Xn equal to k e to the st, and we're going to substitute this back into the equations. So therefore, d square k e to the st dt square, dip twice, right? Differentiate twice, in Thai we can dip. So plus a1, okay, dk e to the st dt plus a naught k e to the st equal to 0. So therefore, if we differentiate this twice, right? So let's see, if my xn of t is equal to k e to the st, dxn dt is equal to sk e to the st, d square xn dt square equal to s square k e to the st. So therefore, this becomes s square k e to the st plus a1 s k e to the st plus a naught k e to the st equal to 0. Right? Well, we can factor k e to the st out, right? So therefore you would have s square plus a1s plus a naught times k e to the st equal to 0. So you have two terms, right? One in a bracket, s square plus a1s plus a naught, and another one is this k e to the st, right? Well, you multiply these two terms together, it's supposed to give you 0. Well, of course, this cannot be 0, correct? Because if this is 0, then my solution, why would I assume that it's my solution from the beginning? So therefore, the only thing that can be 0 is the things that in the bracket. So therefore, this has to be equal to 0. So therefore, we would have s square plus a1s plus a naught must be equal to 0. And this equation is called the characteristic equation. Right? It's called the characteristic equations. And to make these equations come true, the left side has to be equal to the right side equal to 0, you have to find its root, s, the value s, right? And from this, of course, we use our algebra knowledge, back in our algebra knowledge as this, a s squared plus bs plus c equal to 0. So therefore, your s1 is equal to minus b, right, plus square root of b squared minus 4ac divided by 2a, remember, right? S2 is equal to then minus b minus square root of b squared minus 4ac divided by 2a. This is from our algebra. Now we have to apply to this, right? So you apply to this, we will get, right, our S1, change this to our root S1 is going to be minus A1, right, plus square root of A1 square minus 4A naught, right, divided by 2. Our S2 would be equal to minus A1 minus square root of A1 square minus 4A naught divided by 2. Okay, so we will have our roots to be like this. So therefore, our solution, so the solution, our natural response solution would be xn of t would consist of two terms, right, in the form of k1 e to the s1t plus k2 e to the s2t. So this is our natural response form. Okay, and of course to find k1 and k2, right, to find k1 and k2, we need initial conditions, two initial conditions, that is x at 0 and dx dt at 0, and I will show you how to do that later. Okay, now let's go back to S1 and S2. Let's go back to S1 and S2. Okay. Okay. Your S1 and S2. What about S1 and S2? These values. Okay. It seems that, you know, the value of S1 and S2 can be different, right? Can be different. Who remembers? How many? The roots to these quadratic equations can be different, and there can be three ways, right? How S1 and S2 can be different. Okay, so case one, the first case, okay, this is when your S1, right, is not equal to S2. Okay, they are real and they are different values, distinct. They're distinct. So for example, if we have s squared plus 10s plus 16 equal to 0, if this is your characteristic equations, okay, so what are your roots? So therefore your roots would be, right, s like this equal to 0. So you can use a formula, or maybe some of you have learned some trick, you know, or shortcut way to calculate this. So we find what is multiple together to get 16, right, and add together to get 10. So therefore 8 times 2 is 16, right? 8 times 2 is 16, right? And also 8 plus 2 is 10. So therefore it would be plus 8 and plus 2. So therefore your S1 is minus 8 and S2 equal to minus 2. So therefore this is the case, the first case, they're real number and they're not the same, they're distinct. So therefore we can say that my solution is equal to a e to the minus 8t plus b e to the minus 2t, right? In this form exactly. Okay, so this is the first one, and in electrical engineering we call this the overdamped case. Overdamped case. Okay, now case number 2. Case 2. Okay, so in case 2, right, if your S1 and S2 are equal, your roots are equal, both of them are equal, we say that this is a repeated root. Repeated roots. Okay, so therefore your answer in this case, your solution in this case would be yn of t would be in the form of b1 e to the s1t plus b2 t e to the s1t. So they're the same, right? Okay, let me call it that. If I said s1 equal to s2 equal to s, so therefore the answer would be just st, e to the st and e to the st. So e to the st minus b2 e to the st, like this. So this is the second case, and it's called the critically damped. Okay, critically damped. Okay, then the last one, case 3. Case 3. Okay, when your S1 and S2 are complex number. Right? So the value in the square root is negative. Okay, and your S1, when you apply your the formula to find S1 and S2, okay, it turned out to be S1 is equal to minus sigma, okay, plus j omega d, okay, S2 equal to minus sigma minus j omega d, like this, okay, where j is equal to square root of minus 1. We, instead of using I, right, in math class it will be I equal to square root of minus 1, but we cannot use I here because it will be confused with current, right? Current I, so therefore we use j instead. So therefore in this case, if you have a complex roots, okay, your solutions would turn out to be like this: yn of t equal to e to the minus sigma t, okay, k1 e to the j omega dt plus k2 e to the minus j omega dt. Okay, but then, okay, we can use Euler's identities, and it would turn out to be, so that you can make your life make sense out of it, minus sigma t times a1 cos omega dt plus a2 sine omega dt. So this would be the solution for the complex roots. Okay, and this is called the underdamped case. Underdamped case. Okay, so damping, you can see the word damping and damping right here. Okay, what does it mean, damping? Okay, underdamped, overdamped, critically damped. Okay, damping is, you know, it's a gradual loss of initial stored energy. Okay, so what it means is, or in another word, it's a decay, okay, of the natural response towards zero. Okay, it will show you the shape of how it sort of like, decay towards zero, right? So overdamp, you can see it's just exponential. It could be in terms of this, right? This is overdamp, right? Okay, steadily loses the amplitude, okay, right? So underdamp, you can see that there's a cosine and sine, so that means there's some oscillations. So it could be that there's oscillations, right? And then it develop and die out like this, right? So this is underdamp. Okay. For the critically damped, it's like a mix, between the overdamp and underdamp. It could be like it could spike up and then reduce it down later on, for example. Okay, so just an example. Okay, so therefore these are the natural response. Okay, what about force response? Now, for force response, xf of t. Force response. Okay, so in force response, okay, we have to solve the actual differential equations. You have to solve this, okay, and to solve this, okay, we use Triforce Solutions. So there are tables depending on your f of t, your forcing term. We choose what our solution will look like. Okay, and this is Triforce solution xf of t. Okay, so if your f of t is simply a constant, okay, we try that our xf would also be a constant. If it consists of t, it would be, we have to try at plus b as our solution. Okay, if e to the sigma t, we try a e to the sigma t. Okay, if it consists of sine omega t or cos omega t, we have to try our solution to be in the form of a sine omega t plus b cos omega t. If it's in the form of e sigma t sine omega t or e to the sigma t cos omega t, we have to try e to the sigma t a sine omega t plus b cos omega t. Okay, so this is some of the solution that you can try, right? And of course at the end we use both, calculate or analyze both force response and natural response. You add them together and you get your final answers. And the coefficients a and b are in the so-called the solutions from the natural response. You have to use initial values. Okay, you have to know how to find the initial values. Right. So I think that's the review for the second order circuit. Okay, so if you think that you need to go and review your math course, please, you're welcome, and I would love that you do that. Okay, thank you very much. See you next class. Bye.